Welcome to The Explainer. Ever wonder how businesses plan for the future? Without a crystal ball? Well, today we're digging into how they make that leap from just guessing what customers want to actually knowing. It's all about using data to make really smart decisions.
Okay, so here's our game plan. We'll kick things off with the big problem every business faces, uncertainty. Then we'll unpack the two main tools in our kit, estimation and forecasting. We'll see how to make sure they're actually accurate, and then we'll cap it all off with a real-world example to see how it all clicks together. Every business, doesn't matter if it's big or small, is constantly facing these huge make or break questions. And if you get the answers wrong, well, it can seriously cost you. At the end of the day, it all boils down to this one major headache, the certainty problem.
I mean, just imagine this. You're about to launch a brand new product. How many do you make? If you're too optimistic and make way too many, you're stuck with a warehouse full of stuff you can't sell. But if you're too cautious, your shelves are empty, customers are disappointed, and you've just handed sales to your competition. Both are bad news for your bottom line. And that's exactly the kind of risk we're trying to get rid of. So, how do you solve this puzzle? Well, businesses have this really powerful two-part toolkit. First up is demand estimation. Think of this as the detective work. It's all about figuring out why your customers do what they do. Then you have demand forecasting. This is more like being a fortune teller, but, with data. It predicts what is actually going to happen with your sales down the road. So let's dive into that detective work first, estimation. What we're trying to do here is basically build a model that explains what's really going on. And our number one tool for the job is a statistical technique called regression analysis. It's how we uncover those hidden patterns and find out the why behind what our customers are up to. Okay, so regression analysis might sound a little intimidating, but think of it like creating a recipe. The final dish we want to make is sales. That's our dependent variable. And all the ingredients that affect how that dish turns out, things like price or how much you spend on ads, those are independent variables. Regression analysis just figures out the exact recipe that connects those ingredients to the final result. Let's make this real with a simple example. So we've got a Chinese restaurant chain that collected some data from 8 of its locations. They tracked how many meals they sold each day, that's our quantity, Q, and what price they were charging, which is P. Pretty straightforward. Now they take that data and run it through a regression analysis, and out pops this equation. And listen, don't let the numbers scare you. This isn't just random algebra. This is a story. It tells us something incredibly powerful. For every $1 increase in price, the restaurant can expect to sell about 0.44 times fewer meals a day. Just like that, we've put a number on how customers react to price. We've quantified it.
Okay, so we've built a model. Awesome, but is it any good? I mean, how do we know it's not just a bunch of statistical noise or a lucky guess? We've got to put it to the test. We need a reality check to make sure our insights are actually reliable enough to bet the company on.
This visualization here does a great job of showing what we're talking about. So think about how much your sales bounce around from day to day, all those ups and downs, that's the total variation. A really good model, which is that straight line, should be able to explain most of that bouncing around. The little bit that's left over, the part the line misses, that's basically the model's error. So how do we put a number on this? That's where R-squared comes in. It's basically a report card for our model, with a score from 0 to 1. A score of, say, 0.95 is like an A+. It means our model explains 95% of what's going on with sales. That's fantastic. A score of 0.10? Well, that means our model is barely explaining anything at all. And then we have the t-test. You can think of this as our reliability check. If R-squared is the overall grade for our model, the t-test checks each individual ingredient in our recipe. It asks, does price really have a significant impact on sales, or was that connection we found just a random fluke? A strong t-test gives us the confidence that the relationship is the real deal. All right, so now that we have a solid, reliable model that explains the why of what happened in the past, we can finally shift our focus to the future. It's time to talk about forecasting, the tools we use to predict what is going to happen next. When it comes to forecasting, you've basically got two main camps. On one side, you have the more human approach, marketing methods. This is stuff like getting opinions from experts or just asking your customers what they plan to buy. On the other side, you've got the pure math approach, statistical methods that crunch historical data to find patterns. Now, this Delphi technique is really fascinating. It's a super clever way to get the best out of a group of experts without all the usual baggage, like ego or one loud person dominating the conversation.
By making the feedback anonymous and iterative, it forces everyone to really think about their position and nudges the whole group towards a smarter, more refined consensus.
Now, over on the math side, you've got this key choice to make. Trend projection is pretty straightforward. It looks at all your past data, draws a line through it, and just extends that line into the future. But exponential smoothing has a different philosophy. It says, hang on a minute, what happened last month is probably a lot more important for predicting next month than what happened 5 years ago, so it gives more weight to the recent past. Okay, theory is great, but let's see how this all comes together in the real world. We're going to look at a quick case study for a company called Big Sky Foods and see how they use this entire toolkit to build a seriously useful sales forecast. First things first, they got their data in order. And they were smart about it. They didn't just look at their own sales and pricing. They also pulled in data on the average income of their customers and, this is a big one, what their main competitor was charging. They knew all of these things could be driving their sales. And just like we talked about, they took all that data, crunched the numbers, and built their own regression model. This equation is their secret recipe. It tells them exactly how their sales, Q, are influenced by their own price, P, customer income, INC, and the competitor's price, PC. And here is where it all clicks. This is the magic moment. They take that model that perfectly explains the past, and they use it to predict the future. They plug in their own plan price, then they add in an economic forecast for what they think incomes will be, and finally, they make an educated guess about what their competitor's going to do. And boom, there it is, the payoff. The model takes all those different inputs, does the math based on what it learned from history, and spits out a specific, data-driven sales forecast, 31,565 units. They are no longer just guessing. This is a calculated prediction. You know, at the end of the day, all of this fancy math, all these techniques, it's all about one thing. It's about reducing risk. Just like the source material says, the more accurate information you have, the better decisions you can make. It's about taking the guesswork out of the equation, so you're not flying blind into the future. So look, forecasting isn't magic, right? It's not a perfect crystal ball. It's simply about replacing a blind guess with an educated one. And that way of thinking isn't just for huge companies. So I'll just leave you with this question. What's the biggest risk, the biggest uncertainty in your world that you could start to reduce just by looking ahead with the data you probably already have?